me. I'm a pig. Murat, thank you again. I mean, the tee up was uncanny. I couldn't have asked for a better one. So first of all, I'm Eric Van Gieson, as mentioned, CEO of Epoch Epigenetics. I'm going to talk about how I got here, but I have a background both in government, industry, startups. Actually left grad school, did a startup. We got bought by General Dynamics. I didn't like working for a giant company, so I went and kind of did my own thing for a while before I've gotten back into the startup world. And I'll talk a little bit about that own thing that I did. But I think it's really important. I just want to understand the group here. How many of you have heard of Charles Darwin? Okay, cool. All right. How many of you have heard of Jean-Baptiste Lamarck? A few. Okay, that's good. That's pretty good. That's pretty good. They were almost of the same era. They didn't quite overlap professionally. In life, they overlapped by about 10 years or so. But what's interesting is they had completely different viewpoints on inheritance and viewpoints on how the environment shaped you. And so I put this picture up here because I thought it was interesting. That's the same animal, right? These guys, when they live in a barnyard, they're just docile. They might bite you a little bit, but they'll eat out of your hand. They're kind of cute. You get them outside the fence, and they go in the woods, and that's what happens. That same animal turns into that, and that becomes a danger. That kills people, that kills pets, that kills all kinds of things, destroys the environment. Same DNA. That's weird. So who was right, Darwin or Lamarck? In my opinion, Lamarck felt that you could actually be shaped by your environment and that you could pass on the shaping of your environment to your offspring. And it's interesting because this shaping process is something that has fascinated me my entire life. Like, what is it happening that's doing this? And that started me on the journey, right? That started me on the journey that got me excited about something called the epigenome. But I didn't start at the epigenome. I actually started in other parts of biology before I got to the epigenome. And eventually, I had an idea to maybe look at how the world shaped us and use that to diagnose disease. But everywhere I turned, I got told no. I said that everyone I asked that I could possibly get funding from, that I wanted to, when I said, hey, I want to look at how the environment shapes us to diagnose disease. Hey, I want to look at how the environment shapes us to actually understand human performance and look at what we call the host response, or use your body to tell the story of the diseases you've experienced. Every time I had the answer no. And it got really frustrating. It got to the point where I didn't know where to go. I wrote dozens of proposals. I asked leadership in my organizations that I worked for to pay me. Could never make it happen. And so that got me to DARPA, right? That got me to a place that allows you to bring ideas that are a little bit unconventional. And if you can get in, which you have to kind of get tapped to get into DARPA, if you can get in, you can sell this idea to a Jedi Council, effectively, right? So, I mean, literally, it's a Jedi Council. There's people that you have utmost respect for, listening to your ideas. And it's a lot like a commercial pitch. Like if you had an idea for a startup, you would go in and say, hey, I want to do this, and can you fund me, right? And I mean, you've lived this quite a bit. And they usually say no, but in this case, in DARPA, you actually spend about a month or two, and because of bureaucracy, it's taken longer now, but it's going to get fast pretty soon with Tyler McQuaid and his deputy at DARPA. But for me, it was about a month or two, and I got my first program. That's this program up here on the left, okay? And that program, I got $70 million to pursue my dream, right? And I could go to anyone in the world, any company, any university, and I could pursue this dream of using the epigenome to diagnose disease. The host epigenome, not the cancer, circulating tumor DNA thing that everybody's doing and everybody's had a lot of good exits with. But are we doing any better in early detection of cancer? I'm going to say no. And you guys can, challenge me on that. No, the host epigenome. How are we responding to the environment? That was what this program was about in 2017. And when I pitched the program, I got told no at the beginning. But I used data and I used foundational science to actually explain that this is a valid thing to do. And eventually, within the agency, a yes was given. Now, they had to change the policy on how programs are reviewed in my office, Biological Technologies office. In fact, in my pitch inside the office before I went to the Jedi Council, I actually had a person come against me so aggressively that she was yelling in the internal pre-pitch. And so they changed the way in which we could engage new ideas because of that. I proved her wrong, by the way. I proved her wrong. And the director of the agency tried to kill the program. I proved him wrong. And when he left the agency in 2022, Dr. Peter Heinem, when he left the agency, I was the only program manager that he mentioned in his farewell speech as an example of persistence and not giving up to make this happen. But the point here is that I got told no. I had to go into the US government, become a program manager, get $70 million just to make this program work and make the idea real, right? It wasn't just, hey, I write an R01 and I hope I get funded. No, I had to actually be an agent of the government to make this happen. This led to another program called Measuring Biological Aptitude, which led to the creation of a way to measure human performance. There's a paper that's about to come out in Nature. I can't show you the paper right now, but it's going to be cool. We worked with the most elite military operators in the world, and we were able to measure what it took to get into those elite military groups, think Navy SEALs, Green Berets, et cetera. What was the special stuff that it takes to get in? And we looked at the epigenome, the proteome, the metabolome. We looked at pulse ox. We looked at wearables. We looked at heart rate. We looked at cognitive and behavioral functions. All in all, we spent $75,000 per person on this work. And we got some really interesting answers. And that's where I have to stop. But the point is that the underlying technology of understanding how we react to the world around us was supported. And I had to carry this into the government. And in that work, I actually met a really interesting person. A guy named Neil Hermanson. He was a SEAL Team 6 Chief Warrant Officer for 27 years. He built SEAL Team 6 during the War on Terror, along with many of his colleagues, and possibly the most critical part of its existence to actually help us win that War on Terror. He co-founded a company called Epoch Epigenetics with me. And he was at DARPA with me. He was a SEAL Team 6 liaison to DARPA, so he was the guy at DARPA telling me that my ideas actually mattered to the military, or didn't matter. And he thought it mattered, obviously, and he thought it mattered so much that he's joined me in the company. This company has now gone from a DARPA program to a company, okay? It came from an idea that everyone told me no to a company that's now completed its first round of funding, and we're rocking and rolling. We're gonna roll out our first test next year for lung cancer, and then we can diagnose anything, and no, we're not Theranos. And yes, we can do it from a drop of blood. So, okay, just letting you know. But I wanna kind of go back, because my story was kind of, I think, interesting, but the other part of this is that I think there's so much potential in America to actually repeat this story, make it easier, make it faster, and let the next generation of people actually get to a successful company much more efficiently and much faster. And thank you again, Murat, for actually outlining some ideas for how to do that. I think that we can help on both sides. We can build it locally, but we can actually build it from the US government and from the investment side as well. Both sides of the coin have to be really addressed to make people be able to succeed in their startup environment. And so what I'm talking about here is, if you're a life sciences professional, you do go through that apprenticeship that Murat talked about, especially if you're going through academia. And in industry you do, in government and in NGOs you do. And that's been the mindset, right? But there are very few universities that actually preach and teach entrepreneurialism. There are very few universities who actually reward their professors for being an entrepreneur. They get rewarded on H-index. They don't get rewarded on how many companies they've actually spun out of their research programs. And that is something that has to change. If it doesn't change, people are going to sit back and publish papers and be quite content, because that's what they're being graded on. That's what NIH is grading them on, and that is what the university system is grading them on. So that has to change 100%, and that's a US government change. The other thing that has to change that's important, and I don't want to discredit universities who are actually trying to do this, and there are some wonderful examples of academicians. like Jennifer Doudna, David Baker, Bob Langer, other people in this community of academics who have figured out a way around the system to make it work. But they're the exceptions, not the rule. Let's flip that around. Let's make the rule that you can actually succeed in academia, both academically and as an entrepreneur. And I'll give you one example. I was funding a group at Duke University. They were doing epigenetics research for my ECHO program that I mentioned earlier out of DARPA. I won't name the name of the researcher, just to protect the innocent, but he actually was one of my most successful people in my program who I was funding. And unfortunately, he had such a good idea that he wanted to make it commercial. He wanted to spin it out as a company from my DARPA program. And I said, go for it. I'll back you. And in fact, I gave him some extra funding to help his company get started. And I did this with all of my performers. I encouraged them to spin out companies from the DARPA investment. However, Duke University, I'll call him out, told him that you have to choose. You either are a professor or you're an entrepreneur. You are not both. He had to quit his tenured faculty job. And he did. And he took the bet on entrepreneurialism, and he's been very successful. But that should not be a choice. He should be rewarded for that. And that's the point, right? This idea of you can no longer, be academic if you're an entrepreneur has got to change. And it's not, we might talk about it changing, but it's not. So this part of the university or the biological sciences, life sciences career path that doesn't include medtech startup in the curriculum or in the process of thinking has to change. Other thing I want to bring up that's important here is that we are in a great opportunity to do that. Harvard just announced that they're hiring or they're bringing in 75% fewer PhD candidates in life sciences and the sciences in general next year. So they've decided that because there's lack of government funding, they're no longer going to bring in researchers or the pipeline, feed the pipeline of the next generation of researchers. That is a problem. So imagine if industry or if other funding sources besides the US government or maybe part of in conjunction with the US government could help offset that problem. So we have a really unique opportunity right now. The universities are desperate. Their funding is short. They are going to be forced to change their model. I think right now is the time that we force it. And right now is the time that we tell them, hey, maybe you look at other sources of funding. Instead of cutting your scientific research, partner more with industry, think about entrepreneurialism, bring in private equity, in addition to the US government funding. I have some ideas on how that could happen, because I wasn't just going to lay out problems, okay? So, the guy on the left, some of you recognize him. His name is Colonel Jeffrey Ling. He's an MD, PhD, and he's an MD in neurology. He's a PhD in pharmacology. I could spend the next 2 hours talking about him and not cover everything he's done.
You can Wikipedia and
yes.
You'll be impressed if you don't know.
You would be amazed. The thing about him
reports about half of what he's done.
Yeah,
yes.
exactly.
But I want to say this. This man is a national treasure, but I want to also point out three things that he has done that are critical to the success of American biotechnology. Number one, in 2014, he established the Biological Technologies Office at DARPA, okay? Number two, he doesn't get credit for this, but he did the hefty lifting to make ARPA-H happen, okay? 2015, 2016, he started going to Congress. He started finding ways to find funding. He's the one who got the bills passed, or the language written in the bills to help them get passed and bring both sides of the aisle together to make ARPA-H happen, okay? Every time he touches something, it works. And it's not only working, it's doing really well, especially BTO at DARPA, right? If you look at the percentage of investment that BTO has made compared to NIH, and the number of products that are now on the market, Moderna included, that BTO has generated with literally probably 1/1000th the investment. It's amazing. But what he's talking about now is something really innovative, and it goes back to what Murat was talking about. How can we change the way that we fund science in America? And what he's talking about, and I can't say anything more than there's a paper out here, but believe me, people are thinking heavily about this. Could we use the US government as an LP in a state-sponsored fund, just like China, by the way, to combine with private equity to build a massive biotech and medtech investment fund that could put money into the types of technology that our investment community is too scared to invest in. And it's really too scared. This valley of death that Murad talked about between IND and phase 3, no one invests there. Why? You just saw an example of a company that went down after they got through phase 1. I mean, unbelievable. That shouldn't happen. The US and the private investment community should be keeping these companies going to feed the pipeline so that China doesn't beat us in licensures to large pharma. Large pharma should be coming to the US for the best technology in the world. And so, this innovation accelerator, imagine a fund that was created where the US government was the LP and they combined with other giant groups, other giant investors, Catalio, Arch, you can think of the others, Venrock. Imagine this kind of entity existing that could invest and lead investments in these high-risk investments that require patience and require, really innovative thinking, that then could be followed by a syndicate of the chickens, right? The scared investors who won't go against their LPs, and now investment is happening where it's needed. That's what this is about. So I want to end on that note because I want you guys to understand that there is hope. The biotech investment space, even though we've seen cuts in NIH and others, there is hope that there is going to be a massive tectonic shift in how biotech is supported by both the US government and in partnership with the private sector. I'll stop there.